So Tylenol is the most popular form of acetaminophen on the market. Now, Tylenol is a pain reliever and a fever reducer that releases acetaminophen into the system to relieve such pain and such fevers. So it is important for the consumer to know when entering into the drugstore to purchase this pain reliever or fever reducer that they need to know what they're paying for has the fastest rate of release. So in lab 3, we tested 3 different types of acetaminophen for rate of release to see which form releases acetaminophen fastest into the body. Now, 3 types were tested: the tablet, the caplet, and the gel cap. Now, the hypothesis at the beginning of the experiment was that the tablet would have the fastest rate of release. Now, why is that? The tablet has a larger surface area, as well as there's no outer coating on the tablet compared to the caplet or the gel cap. So once the tablet enters into the stomach, it immediately begins to dissolve. Now, what is the real-world application of this? So, in 2018, a study was conducted by Voucher Research on Tylenol's rapid release gel caps that were more expensive than the standard tablet. And what was found by this article in the New York Times was that the gel cap was actually 30 seconds slower to dissolve than the cheaper tablets. Now, why is this an issue? As I said before, the gel cap were more expensive and promised a rapid release compared to other forms of Tylenol that were available at the time. So consumers are paying for more and getting less, which is a huge issue for the company as well as the consumers buying that product. Now, the procedure first began with a standard formation of Pheroin. Now, why was Pheroin important? Pheroin is the solution that we were using in the Spectronic 200 spectrophotometer and measuring for absorption in order to determine the concentration of our solutions later in the lab. And then we have our standard curve of Pheroin in the absorbance versus concentration. And it was important to get the slope and the intercepts off this to use later in the lab. So the second part of the lab involved using 700 milliliters of hydrochloric acid. Now, why is that important? Well, the hydrochloric acid was heated in the beaker and used to simulate the environment of the stomach. Now, it's important because this was the way to get the most accurate test for the different forms of acetaminophen dissolving in the stomach. Now, the solution had a T-ball suspended inside of it, and inside that T-ball was that commercially available form of acetaminophen. Now, over a 30-minute period, every 2 minutes, a sample of the hydrochloric acid was drawn, and it was then heated, cooled, and later turned to Pheroin so that the absorbance could be tested of that concentration. Now, we did that for all 3 forms of acetaminophen tested in this lab, and the results are as follows. So, looking at these 3 graphs of acetaminophen dissolved versus time in minutes. So, our first is the caplet. The caplet has a steady rise in slope. So, it more of a standard release of acetaminophen. Now, the tablet, looking at the first 5 minutes, looking here, the caplet was much slower in that first 5 minutes, releasing under 200 milligrams of acetaminophen. So next is the tablet, and looking at that in the first 5 minutes, almost doubled the caplet. Now, looking at the release in the first 5 minutes of the gel cap was also slower and similar to the caplet rather than the tablet. However, overall, looking at the complete 30-minute time period, we see that the caplet over time eventually, or the gel cap over time eventually released the most acetaminophen. So one of our final calculations involved that total, that the milligrams released per minute, which were used to form these graphs here. So this calculation was a simple slope calculation using the endpoints for each of those graphs. So for example, the caplet, we have that 600.45, subtracting that lower first first data point, and then you taking the X value of 14 minus 2, and ending up with 44.694 milligrams released per minute. So looking at this overall throughout the experiment, we have the caplet, the gel cap, and the tablet. Now, in rate of release in milligrams per minute, is the gel cap was double that of the caplet and much more than double that of the tablet. And the amount released for both of those was, for the gel cap, was much larger as well. Now, this was a surprise in our experiment, and compared to the rest of the class, this was the only experiment in which the gel cap out-succeeded the tablet. So in this lab, as I stated, the procedure was very extensive. So there was much room for error in this experiment, such as, if the gel cap's dissolving and a chunk of the gel cap comes off when dissolving, or something like that, or the T-ball is holding it back, or there was a temperature difference as the hydrochloric acid was heated. So there was a large room for error in this experiment, but overall in our experiment, the gel cap had the fastest rate of release and the most released.